We're on page 69, topic 14. We're going to solve quadratic equations by factoring. And so we've got on page 69 three problems. I'm going to do all three of these problems, go over them. And the most important thing also that we learn here is that each solution can be checked in the original equation. So we're going to do that too. So let's start with example 1. Here we have 6x squared minus 3x equals 0. And so we look for the greatest common factor. First of all, the very first thing we do, and we can factor out, you look at the 6 and 3 here, the highest number that we can factor out is 3. And we've got x squared and x, so we can factor out the lowest power of x, which is 3x. So we open up the brackets. 3x times 2x gives us a 6x squared by the distributive rule, and 3x times minus 1 gives us minus 3x. So we've now factored 6x squared minus 3x equals 0. And by the zero factor property, in other words, if the product of two numbers equals 0, either this, the first one, equals 0, or the second one equals 0. So if 3x equals 0, x equals 0. If 2x minus 1 equals 0, which is this one here, then we transpose the minus 1 from the left to the right and make it plus 1. Divide 2x by 2 and we get x. Divide 2x by 2, we get x. Divide 1 by 2, we get 1/2. So the two solutions are x equals 0 and 1/2. Now we're going to check this solution. Go back into the original equation. The left side of the equation is this. And, well, if x is 0, x squared is still 0, and 6 times 0 is 0. If x is 0, 3 times 0 is 0. So the left side equals 0, and the right side equals 0. And since the left side equals the right side on the check, this is a valid solution. Now we check the other one, which is x equals 1/2. We put it into the left side of the equation, 6x squared minus 3x. We always go back to the original equation here. We get 6 times 1/2 squared minus 3 times 1/2 if we replace the x with 1/2. Now, 1/2 squared is 1/2 times 1/2, which is 1/4, and 6 times 1/4 is 6/4. So this becomes this here. 3 times 1/2 is 3/2, because remember the 3 is 3/1. So we multiply the top of this by the top of that, we get 3/2. 6/4 reduces if I divide 6 by 2 and the 4 by 2, both of them, this reduces to 3/2. So I have 3/2 minus 3/2, which equals 0, and so the left side equals the right side because the right side of this is also 0. So let's go to example 2 here. Solve x squared equals 4x minus 4. First thing we do is transpose the 4x and the minus 4 to the left side. So the plus 4x becomes minus 4x. The minus 4 on the right becomes plus 4 on the left. And now it's in the standard form, ax squared plus bx plus c equals 0. Ax squared plus bx plus c equals 0. And now I factor this, and this factors its perfect square. So it's x minus 2 and x minus 2. So it doesn't matter which one of these two you take. I mean, the solution is going to be x equal 2. There's only one solution, and it's 2. In this case, because there's more than one way, essentially, that we get the answer, we call it a solution of a multiplicity 2. There are two solutions that give 2 as the answer. Now we check the left side of the equation, which is x squared, and 2 squared is 4. And the right side of the equation is 4x minus 4, which is 4 times 2, or 8, minus 4, which gives me 4. Since the left side equals the right side with the value of x equal to 2, this is an acceptable solution. So now we go to the last example, which is x cubed minus 9x equals 0. And there's no number that we can take out of both of these, but we can take the lower power of the x. This is x cubed, and this is x to the 1. I take out x to the 1. X times x squared gives me x cubed, and x times minus 9 gives me 9x. So now this is the difference of squares. So I've got x plus 3 and x minus 3. Notice there's no middle term here. This is a perfect square, and this is a perfect square. The plus 3x inner term is canceled by the minus 3x outer term. So we've got x plus 3 and x minus 3 are the factors of x squared minus 9. So we get this equal to 0. So either this is equal to 0, the x plus 3 is equal to 0, or the x minus 3 is equal to 0, according to the 0 factor property. And we've got 3 possibilities of these being 0. So the solutions are 0, minus 3, and plus 3. In other words, if this is x plus 3 equals 0, then I transpose the plus 3 from the left to the right, and I get minus 3. If x minus 3 is a solution and I transpose the minus 3 from the left to the right, I get 3 plus 3. So here I check each one of these solutions. I put it back into the original equation, which is right here. And you can see when x is 0, obviously x cubed is going to be 0, and minus 9x is going to be 0. So I get 0, and the right side is 0. If I check 3, x cubed will be 27. Minus 9 times 3 will give me minus 27. I'll get 0 again, and here I get 0. Now if x is minus 3, this is x cubed minus 9x. X minus 3 times itself 3 times gives me minus 27. Minus 9 times x minus 3 gives me plus 27. So the minus 27 and the plus 27 sum to 0, and the right side is 0. So this completes page 69 and the introduction to examples of factoring.